Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching food machinery in B 5th semester. Today we will do our next class. Today we will discuss this numerical. A jet of water having velocity of 35 meter per second impinges on a series of vanes moving with a velocity of 20 meter per second. The jet makes an angle 30 degree to the direction of motion of vane when entering and leaves at an angle of 120 degree. Draw the triangles of velocity at inlet and outlet and find first the angles of vane tip so that water can enter and leave without shock. The work done per unit weight of water entering the vane and the efficiency. Here the data given are velocity of jet V1 equal to 35 meter per second. Velocity of vane U1 equal to U2 equal to U is equal to 20 meter per second. Angle of jet at inlet, alpha equal to 30 degree, and angle made by jet at outlet with respect to the direction of motion of vane is 120 degree. So here angle beta is equal to 180 minus 120. This is 60 degree angle beta. Now angle of vane tip, here this is the velocity triangle at inlet. This is U1, this is VW1, this angle is alpha, this is theta, VF1, and the outlet triangle, this is angle phi, this is beta, this is angle is respected by 120 degree. This angle is given 120 degree, but as we know this is 90 degree, so this angle is 30 degree. So 30 plus beta plus this 90, this angle is 90 degree. So this angle beta is equal to 60 degree. Now we have to calculate for the angle of vane tip. Angle of vane tip from inlet velocity triangle. This inlet velocity triangle, as we know, VW1 equal to V1 cos alpha. So putting the values of V1, that is VW1, this is VW1 equal to V1 cos alpha. So putting the values of V1 equal to 35 and cos alpha, the value of alpha is 30 degree. So that is cos 30. Now this value of VW1 is 30.31 meter per second. Now VF1 is equal to V1 sin alpha. V1 sin alpha. This is VF1 is vertical component, so this is V1 sin alpha. Putting the values, the value of V1 is 31 and sin 30, so this is 17.5 meter per second. Then theta here, then theta equal to VF1 by VW1 minus U1. In this figure, tan theta equal to VF1 by this much. So this is VW1 by U1, and we are having the values of all this by putting the values of VF1 and all this. 17.5 divided by 30.31 minus 20, so we are getting this 1.697, and the value of theta is here 60 degree. This is value of theta is 60 degree. Now by the sine rule, V R1 by sine 90 equal to V F1 by sine theta, or VR1 by sine 90, the value of sine in this small triangle, no? So that is VR1 by 1, value of sine 90 is 1, that is 17.5 by sine 60. So here the value of VR1 comes 20.25 meter per second. As the water enters and leaves without shock, so this VR1 equal to VR2, this whole is equal to 20.25 meter per second. Same values are here, 20.25. From outlet velocity triangle, in this triangle, outlet triangle, by applying the sine rule, VR2 by sine 120, VR2 by sine 120 equal to U2 by sine 60 minus 5 sine 60 minus 5. Here this is sine 120 and 60 minus 5. This angle is 60 degree. Okay. Now putting the values here, the values are 20.25 by sine 20, value of sine 20 is 0.886 equal to U2 is 20 by sine 60 minus 5. So here the value of sine 5, here sine 60 minus 5 is equal to 0.855, that is the value of sine 58.75. 58.75 degrees. So 60 minus 5 equal to 58.75. So the value of phi is equal to 60 minus 58.75. So this value comes phi equal to 1.25 degree. The value of phi comes 1.25 degree. Now calculating the work done per unit weight of water entering work done. This is equal to 1 by G V W1 plus V W2 into U1. So here putting the values of VW1 and U1, the value of VW2 obtained from the outlet velocity triangle. From this outlet velocity triangle, VW2 equal to VR2 cos phi minus U2. Putting the values here, 20.25 cos 1.25 minus 20. So this value of VW2 equal to 0.24 meter per second is the value of VW2 here, and work done per unit weight, work done is equal to 1 by 9.81 into 30.31 value of VW1 plus 0.24 multiplied by 20. So this value of work done comes 62.28 Newton meter per Newton. Newton meter per Newton. This is 8. This is 8. Now for the efficiency equal to work done per kg of by energy supplied per kg. Energy supplied per kg. So this is 62.28 by V1 square by 2G. Putting the values here, 62.28 into 2 into 9.81 is divided by 35 square. So this value of efficiency comes 99.74% is the efficiency for this question. This question has been asked in university exams, and you have to solve this type of questions number of times, and questions asked in the university.